Well, thanks for having me and having Gretel. So my name is Maarten. I'm leading the applied science team at Gretel. Been working for Gretel for 2 years. Before that, spent time at Amazon, many years there, and then before that, Qualcomm. So what is Gretel? Gretel is a synthetic data platform, and our mission is to take better data to make better models. If you look at our users, we have a lot of community users like software developers, individual users. We also have enterprise users, all using our SDK and our console. It's quite popular. And what they all have in common is they have a bottleneck that is around data that is hurting the way they can innovate not as fast as they want. And all these data issues are related to either they have missing data, the data is not annotated, they have data but they can't use it because of privacy and security reasons, or they have biases in the data. And so we'd like to solve that using synthetic data, generating synthetic data for them. There's many definitions of synthetic data floating around. I think the one we stick with is it's created by generative AI models as an alternative to real world data. So it's data that looks and feels like the real data, but it's generated by models. And it's also, because it's generated by models, you have control over the data and you can generate it in the way you like it for your downstream application. Before I dive into the rest of the talk here about how we use synthetic data for fine-tuning SLMs, I'd like to talk a little bit of the GenAI waves we have seen, and maybe there's a little bit of an oversimplification, but in 2000s and whatnot, we had the compute wave, where people realized that they can train those large neural networks on GPUs, and so they can create these larger models and train it on larger amount of data. Models like statistical models, Gaussian mixture models, they became obsolete and all replaced by these deep learning models. Then we had the model architectural wave. Libraries like PyTorch, TensorFlow came around, and all these scientists could build different architectures. Like in the 2010s, every week there was a new model architecture coming out, or ResNet, ResNet, SkipNet, and all these models. And so and then at some point the transformers came, and for the last few years, I think it's like an architecture that sticks most of the time with many. They're not saying there cannot be improvements or iterative improvements, or other architectures can come in the future, but that's what we've seen so far. And right now we're actually entering a data-centric wave, where the focus is to focus on high-quality data to better boost the performance of models. It's actually very actual. All these articles that I have here in the news are appearing the last few weeks. There is this article where they're stating that the AI is running out of their of their most valuable resource, which is data. Even Sam Altman of OpenAI admitted in the article that they're looking into synthetic data to overcome that gap. We have another article about other companies that are building foundation models that have been accused of scraping the web in ways that there's no limitations. And then the other article in New York Times is actually citing a work of an academical study, where they actually saw that more and more websites and open source data communities putting restrictions on their website to prevent crawling the web and including their data into so that it prevents to be used for training data for large language models. We see a lot of challenges with our customers with respect to building GenAI solutions. The first one is they have data, but it's messy data. It's actually the best case scenario, but it's still, they have to do a can-do attitude that's required to clean up the data, to spend a lot of time wrangling with the data. The data is still not perfect. Worst case scenario is they have no data. They might not use the data, or the data doesn't simply exist, right? And all this leads to weeks of months of trying to find data and getting stuck. And ultimately, it might lead to AI projects that never see the light at the end of the tunnel. Enterprises have also challenges. Some of the time they have data, but also data brings challenges. Security considerations. It becomes very hard to, with all these regulation, around GDPR and HIPAA, to how to manage the data in an optimal way. There's data silos that happening. The risk of breaches, of course, and they're looking also into synthetic data as a solution to all these challenges. However, synthetic data generation by itself to an LLM also has restrictions. Some like ChatGPT, OpenAI, they have a policy in place that you can generate data, but you cannot use that data to train competing models, and that's also a very vague term, because can you train a task-specific SLM to compete with ChatGPT, right? So it's a very vague, terminology, and that can lead to legal and licensing issues. It's also not clear who owns the data. Like if you generate data through a closed source LLM, do you own that data, right? So the open source, open weight, open data discussion here is also important. And we at Gretel take all these considerations in mind, that the synthetic data that you generate through Gretel is owned by you, and you are free to do whatever you can do, because we are relying on the open source and the open data community as well when we're building things out. We have already seen that synthetic data is disrupting some parts of AI and ML. Databricks realized that if they can inject high quality synthetic data, they actually need less the amount of total data for training their model. Microsoft has been innovating on synthetic data sets while building their fee models. Same with Cohere and Google and Gemini, that they're starting to look in utilizing synthetic data to complement the training data they use for making those foundational models. So now let's talk about Gretel and what we're building to specifically for the use case of large language models or small language models. First of all, we're a multimodal synthetic data platform. We're supporting not only free text, but also tabular data, time series, highly dimensional data. Image is something that we have on our roadmap. And besides generating synthetic data for it, we're also taking privacy in mind. So we're using techniques like differential privacy to give mathematical guarantees that, if you fine-tune a model using Gretel on your data, that the synthetic data that is generated by the model doesn't have a risk to get re-identified on your original data. We have privacy filtered privacy reporting and stuff. That's something that we take in mind here. So when we talk with our customers, most of the situations we encounter are one of those three things, right? Either you don't have any starting data, so what you do, you need to generate data from scratch, or you have data, a few examples of data, but it's incomplete, and you need to boost your data, generate more data, and augment it with your data, or fill in the missing blanks in your data sets. Let me talk about those two topics first. So for this, to deal with those two, sparsity of data or lacking of data, we built the Gretel Navigator model. And so Gretel Navigator is a compound AI system. So compound AI system is a term that was coined not so long ago. It actually means that it is, a system consisting of multiple agent tools that work in close collaboration with each other to execute on a project. In our case, a user provides a prompt, which is a description of a data set, and our compound AI system tries to give the best high-quality data set that matches that prompt description. An example is there. You can also use it. We have a demo booth there, so happy to give some demonstration there, right? I think it's important to state is that those agents and tools are LLMs, but they're not only LLMs. So there's LLM heavy, but there are also other tools that are part of the compound AI system to, fill the gaps for LLMs. LLMs are so far not so great in math. They're not great in generating a huge list of unique identifiers like social security numbers and whatnot. Making those LLMs work with other agents, functions, maybe Python functions in such a way that the highest quality synthetic data is generated. That's the ambition of our compound AI system, which is called Gretel Navigator. And to give one example that we've done here, we created this world's largest open source text-to-SQL dataset that we put on Hugging Face. Open source, free to use by anyone. Became very soon the #1 trending dataset on Hugging Face, has 100,000 records. We even got a shout out from Clem, who's the CEO of Hugging Face. And so got a lot of good comments there. The use case actually, so you may ask, why would you generate such a data set, right? So think about that you would like to talk to your database in a natural language way, right? Without you writing the SQL query, right? So you can think about an LLM that can be trained on this text-to-SQL database that then can, converse your natural language into a SQL query and then retrieves the desired outputs from the database for you, right? So one of those example records is here. You can see there is a prompt, which is a total number of hospital beds in each state. There's a SQL, counterpart of that prompt. And what's also nice with synthetic data is that you can add a lot of metadata there, a lot of domains. You can tell the Navigator model to generate from healthcare, from finance. You can say, I want complex queries with a lot of inner joins and whatnot. So you can drive the synthetic data in such a way that you want it for your application. In this case, we just created from scratch a generic data sets that we think it would be used for a wide case of SQL data sets, but some customers have like specific SQL dialects or specific SQL limitations or whatnot they want to do. We fine-tuned the model and then tested that model on the BERT benchmark, which is an independent benchmark that has nothing to do really with the dataset we were generating. We did that with Predibase. My colleague Jeff worked with Predibase and used Predibase framework to basically fine-tune those models, and we can see for all these small language models here, which is MetaLlama 3, Microsoft V, and Mistral model, we saw that all these small language models trained on the synthetic data and then tested on this separate benchmark data set got all boosted with some quite large margins. So really the power of synthetic data speaks here to boost those models. So build better models faster, fast to generate synthetic data, and better models that can be generated from those. The last thing I like to mention here is the third point. Sometimes customers have data. They want to train an LLM on it, but they can't because the data is highly private, sensitive, secure, it has patient consent or whatnot, then they cannot use it because it's very sensitive, right? And also for that, Gretel offers a solution there. The solution is to create differential private synthetic data. So we're training a model, we fine-tune a large language model on your data with differential privacy technique implemented to create data set that looks and feel like the original data, but by no means can be re-identified to your original data. Let's take this example here as an illustration, right? It says, patient John Doe, 32-year-old male from Springfield, presented with a rare form of hemophilia. He mentioned that his condition worsened after participation in the city's marathon last month. So traditionally, people would just redact it. They redact the name, the age, the gender, location. Redacting the gender doesn't really make sense if the next sentence starts with "he mentioned," right? But there's still a risk of re-identification because if you know someone that has symptoms of hemophilia and you also know that the person participated in the city marathons, you might be able to re-identify the person, right? So a differential private version of that would be a 35-year-old patient, so somewhere in the age range of a mid-sized city, presented with hemophilia, and there's a correlation with the diagnosis of hemophilia and the fact that he participated in a community sports event recently, right? So anyway, this data set has the same insights that you want to retrieve from the original data, but no way you can re-identify a person. So we have a model called Gretel GPT, which is basically allows you to train or fine-tune models, fine-tune LLMs with differential privacy in mind. And differential privacy means actually means that you inject noise during the training to prevent exposing this sensitive information. We're supporting models that can be trained with LoRa, parameter-efficient fine-tuning. You can bring your own model to that. It just needs to support PEFT. And there's obviously a privacy quality trade-off that you can control in your configuration, which is an epsilon factor. The lower the epsilon, the more privacy. If you set epsilon to 0, you just generate random noise, obviously. The higher the epsilon, if you set it to infinity, it basically means you train with no differential privacy. So it is the tuning factor. And as you can see in these graphs here, if purple is trained without differential privacy, the green bars are with differential privacy, and the synthetic semantic scores are very similar between that on those two data sets where we actually fine-tuned on. So where are we headed? The future of data, I believe it's synthetic. I have two quotes here. One is from Gary Marcus. He's an AI analyst, but also emeritus professor of NYU. He said that people had the illusion that you could infinitely make large language models better by just using more and more data, but now they've basically used all the data they can. And the second quote is from Wizard LM. That's a team behind a Microsoft team behind the Wizard LM model. As the nature world's human-generated data becomes increasingly exhausted through LLM training, we believe that the data carefully created by AI will be the sole path towards more powerful AI. And so this all fits into a prediction that Gartner made already in 2020, where they say that the data that is going to be used for synthetic data for AI will be dominated by synthetic data by the year 2030. And so that's also a trend that we're actually seeing in the world. And when we talk with customers, they want to adopt synthetic data more because, they have data, they cannot use the data, or they're running out of data. Before I conclude, here's two QR codes. You can sign up for Gretel. You can really use our models. We have more models than the one I presented. We have free credits as well that you can use. And a good demo or video is our Gretel University. We also walk you through some of our models as well. And that's it. Thank you.
Thank you so much, Maarten, for the talk. Any questions on synthetic data? Let me go here, and then we'll go back there.
Thank you. My name is Spark. I'm a solution architect. Thank you for the sharing. And sometimes we heard two sides of a story. One side of the story is, hey, we should use some way to generate the synthetic data so we can put things further. However, sometimes we heard another story that we are afraid that when synthesized data, we're going to introduce some bias or maybe make the hallucination even worse. So I think you are the expert of synthetic data. How do you control the quality to make sure it's going the right direction?
And you can even add a third, like model collapse. If you train on synthetic data and you use that model to further generate data. I think it's very important that, synthetic data is not always a replacement for your real data. So merging real data with synthetic data is always a good idea. The other thing is just blindly trusting all the data that's come from an LLM might also not be a good idea, right? So you have quality checks need to be in place. When we created the text-to-SQL data set, it's not just the output of an LLM, it's the output of an LLM that's been validated to an agent that's checked for synthetic, semantic correctness, make sure unit tests are passing and whatnot. So it's also part of the system that you want to build to create those evaluation and validation checks in place. Techniques like LLM as a judge, where you rely on another LLM to basically assess the quality of the synthetic data, that's also important, right? So yes, synthetic data is great, but you need to provide high quality synthetic data, and everyone can create synthetic data, but high quality synthetic data is really something that's very valuable for us. Thank you.
One more question over here. One home.
Thank you. Eugene, I'm product manager. In your example of generating the synthetic data with the marathon hemophilia, the understanding what parts are important came from the domain expert, right? So could I specify that the marathon is important versus not?
Yeah, I mean, it really depends on that's a good question. It really depends on the use case itself, right? So if you want to build, let's say, a RAG-based system where you want to retrieve exact properties from a particular patient or user, then you have to not replace it by synthetic data, right? So there's this balance, what you'd like to do. I think when it comes down to, the semantic similarities, if you're okay that the text is semantically similar than the original text and you don't care about, the actual entities, the actual individuals, then synthetic data is a good replacement. So yes, it's a balance, and you have to, yeah.
We'll do one last question just over here.
Hi, thank you. Daniel, thank you for your talk. Very interesting. I want to add two parts to this, but the first, do you think, coming back to the quality question, is the sheer quantity of the data something to attain? Can you use perhaps some of the methodology you've done here to help filter out the noise of the existing data that we have? That's the first, and I'll come back to this.
And with existing data, you mean the real world data? And how would you then assess that? You would use the real data as seeds for or navigator model, let's say, to assess how good that quality of the data is, and then filter out records. Yeah, I mean, you can use LLM as a judge type of techniques to do that.
Okay, so
it's complex. I would say there is some complexity on that. Yeah.
Okay, because you're using some of the patterns in the data to create your own. Right?
Yes.
So the high quality that you create is a representation of the patterns that you've extracted, right? So maybe you can use some of those techniques to help filter out and reduce the amount.
Right.
So, right. Okay, thank you. And second part, are there any particular use cases that you find would be, apart from really relevant, some that would be not as relevant? So let me give you an example. Say I'm creating a predictor for a soccer game, right? And so those events are real events, right? And maybe I would not like a synthetic data that says, Holland plays Argentina, and it says Holland beats Argentina absurdly by 6 goals, right? So any kind of scenarios that you think would be useful compared to those that, real events that are hard to create synthetic data for.
So, like creating data for outliers or for things that are not observed but are still useful to have. Yeah, I mean, you can bias the model. Once you have the model, you can bias it. You can ask it to conditionally generate data in the certain direction that you want, and then it's the way you specify it. You want high scores that are unrealistic, or you want to have scores that are very realistic. You can tell or guide the model in a way to give it the data you are desiring to have.
Thank you very much, Maarten, for the talk.
No problem.